Thank you very much for having me here today. I really appreciate it. I'm really excited about what you all are doing here in North Carolina. I believe it'll be 27 years this fall since I taught my first quantitative reasoning class. And I think I've been proselytizing for this ever since. And I think North Carolina is the first state that, as a state, really completely jump on board. And so I have really two goals. I have two basic goals tonight. The first and most important one is to keep you awake. I know it's going to be tough right after dinner. And then the second one is, I know most of you are all bought into this idea already, but just in case, to make sure you have a really good sense of what this idea of quantitative reasoning or math for life, which I think are essentially synonyms, really means and why we need to do it. And I thought before I get into this, I'd just give you a little background on how I got to be here, which is that 27 years ago when I was finishing my PhD, the University of Colorado set up a faculty committee, to decide what they should do with their liberal arts math curriculum. And the reason was because they decided it wasn't working the way it was, because the vast majority of students were taking, well, actually at the time, none, but they put in a requirement that you had to take one math course. So the vast majority of students were taking only one math course in college. And what they were taking was college algebra. And as an algebra textbook author once told me, he said when people ask him to explain the difference between high school algebra and college algebra, it's actually a very easy thing to explain, he said. You just tell them that in college algebra, we teach the same things that we teach in high school algebra, only in college we teach them louder. And of course, you can see immediately why, if that's the only math course someone's going to ever take in college, and they've already taken high school algebra, especially in that case, what's the point? And so the university decided that they were going to do this quantitative reasoning thing, but they didn't know what it meant, so they had a committee put together to decide. And apparently, I wasn't at the first meeting. It was a faculty meeting, interdisciplinary, about half from math, half the rest from other departments. They all looked at each other and said, what does it mean? And they had no idea. And somebody said, well, wait, what about that grad student who's finishing his PhD who just built that model solar system? He must know something about math education. So they invited me to join the committee. And then they asked me to create the course. And at the time, there was nothing existing for quantitative reasoning. As far as I know, it was the first quantitative reasoning course in the country. So I had to write my own materials, which is how I ended up being a textbook writer, because I was developing the materials for that course. Anyway, then I decided more recently to try to do something for people who don't have time to spend a whole semester in a college course. So this is sort of the general public version of my textbook, and designed really to give you a sense of why I think this is the way that you're all going, why this is the right way to go for our students who are not in math, science, and engineering majors. Those students obviously need to go into calculus, but for the rest, especially those who this is going to be their last math course that they ever take, let's do something that's going to be really useful for them. So that's what I mean by math for life. It's the math that they are going to really need for the rest of their lives. I know a lot of you are familiar with the book, but I just thought I'd show you the table of contents briefly to give you a sense of the kinds of topics that are in Math for Life. It's very different from a typical mathematics course. This is not an exhaustive list. It's just a sample that I included. But thinking with numbers, statistics, money, taxes, deficit and debt, energy, political polarization, growth, these are all Math for Life topics. And I'll give you a few examples of them tonight. So I want to start with a question. I actually start each chapter with a multiple choice question. So here's the first one. You've just struck up a conversation with a dynamic, successful businesswoman. Which of the following are you most likely to hear her say during the course of your conversation? A, I really don't know how to read very well. B, I can't write a grammatically correct sentence. C, I'm awful at dealing with people. D, I've never been able to think logically. Or E, I'm bad at math. It's quite clearly E, but when you think about it, that's pretty darn crazy. How does somebody to get to be a successful businesswoman being bad at math? Now, one of the interesting things about this particular question is the truth is there's no way she got to be a successful businesswoman being bad at math, right? She's probably actually pretty good at it. But she'll say I'm bad at it. Why? Well, I think Suzanne has a little flu or something, so she can explain the reason. It's because it's a contagious disease. You hear one person say, I'm bad at math, and they're successful, so you think, hey, I could be bad at math too, and I'm successful, right? And then you tell it to the kids, and the kids go, oh, good, I don't need to know any math, because it's okay to be bad at math. And you see how it spreads like a disease across society. So the very first message I like to give to people, now, of course, with you all, it's not so important, but when I'm talking to a general public audience, is even if you think you're bad at math, don't ever say it again. Otherwise, you will be transmitting that disease. Now, of course, for our students, they may come in wanting to say that. We want to change them during our semester with them. First, we have to convince them why they should be in a math course, especially one that they've never heard of, like quantitative reasoning or math for life. And there's a few ways you can go about it, depending on the student. The first way you might go about it, I know you can't read this from there, but this is the top 20 majors by mid-career salary listed there. And if you were up closer, you would see that pretty much all 20 of them require fairly advanced mathematics. So the first reason why you should not be bad at math is because if you want to make a lot of money, you shouldn't be bad at math. All the best careers, or most of the best careers, require some fairly advanced math. And incidentally, even though this course is aimed at students who say they are never going to take another math course again, you will find some of them change their minds over the course of your semester. They'll go, wow, I thought math was always dull and boring. I didn't know it could be this fun. And some of them will say, in that case, you know, hey, maybe I will go take calculus. And then they do move into these kinds of careers. Well, of course, you're going to have some students who are not so interested in money per se, right? They just want to be happy. Here's the top 20 jobs by job satisfaction, according to a recent survey by jobs.com or something. If you can't see it from the back, number one job by job satisfaction is mathematician. And you didn't even know you're that happy, right? But you are. You are. And again, when you look down the list, there's a few exceptions, but for the most part, these are all jobs that require some fairly sophisticated mathematical training. So it doesn't matter if you want to be rich or you want to be happy, you need to know mathematics. Then, of course, some people will say, well, I'm not just about me. And so then you have to say, well, why, even if you don't care about the mathematics yourself and you don't mind being unhappy and poor, what about the consequences to society? And so I like to give this example here, which is that, as you know, our economy is still pretty weak and we've had a lot of problems, and they're all pretty much traceable to what's called the popping of the housing bubble a few years ago. And, you know, for most people, this housing bubble popping was this incredible surprise. This graph on the axis here plots the ratio of household income to, the ratio of home price to household income. So in other words, a value of 3 means that if you earn $50,000 per year, you buy a $150,000 house. And this ratio, I know you can't read the numbers from there, but that line there is just above 3. So for decades, you know, it moved around a bit, but for decades it basically sat around 3. If you made $50,000, you bought a $150,000 house. But starting about 2000 and then jumping up to 2007, it popped up to almost 5, which means the same person earning $50,000 a year, instead of buying a $150,000 house, was now buying a $250,000 house. Now you can ask yourself, does that work? No. Still no. All right. All right. You can ask yourself, how is it possible that the same person can suddenly afford a much more expensive house? And there's 3 possible answers. Number 1 is their income went up a lot, so they can spend a higher percentage on housing, but it didn't. And in fact, nationally, incomes were not rising. The second possibility is they cut spending on other things so they could afford it. But they didn't. Lending other debt was actually going up at the same time. And that leaves only the third possibility, which was they were borrowing more money than they could afford. And if you think about that, it is inevitable that that's going to come back down. How is it that nobody saw it coming? Well, of course, there were people who saw it coming because this data was available. But most people didn't. Why? Because they were bad at math. That disease caused our recession. So we had a math recession in the 2000s, and we are still suffering the consequences of, as a nation, being bad at math. Also, I want to point out here, there's a lot of math in this graph. There's reading graphs, right? There's ratios, right? There's understanding the statistics of incomes and prices. There's exponential growth, because if you want to understand what a mortgage is, you have to know exponential growth, right? There's actually, you could even talk about rates of change here. There can even be calculus in this. And then ask yourself, where in the normal math curriculum would any student ever encounter this highly mathematical topic? And the answer is, in the standard math curriculum, nowhere. No wonder we're so bad at math as a nation. We don't cover the important mathematical topics, ever. And that's what you're going to be able to do now through quantitative reasoning. I want to give you a few more just samples of the kinds of things that make up quantitative reasoning, just to give you a taste. So the next topic I like to talk about is what I call thinking big, and there's this famous quote from Everett Dirksen, the senator, "A billion here, a billion there, soon you're talking real money." And this is because if you talk to students, or the average American, you will find that they all know that 10 is bigger than 1, and that 100 is bigger than 10, and that 1,000 is bigger than 100, and that 1,000,000 is bigger than 1,000. But beyond that, million, billion, and trillion are only changes in consonants. They have no real meaning. People interchange those all the time. You think it was a slip of the tongue. No, it was a slip of the brain, because they don't know the difference. So you can do things to help them understand it. But again, we never teach this skill, even though it's very, very important. So for example, my first one, you have a pro athlete who earns $1 million a year. How long will it take them until they've earned $1 billion? Okay, you all know the answer. It's 1,000 years, right? Students, or the average American, when they see that, they're like, oh my God. How can $1 million a year still take me 1,000 years to get to $1 billion? And there's all these people on the Forbes list who are multi-billionaires, right? How's that possible? How many employees could you hire with $100 million? Well, imagine, there's lots of debate about income inequality and whether the pay of CEOs and so on is too high, too low. You can have your opinions on that debate, but I want you, instead of having your opinion, to put yourself in the place of a board of directors member for a big corporation. Your corporation has done fantastic under your current CEO. Stock prices going through the roof. The CEO wants $100 million to stay. Okay, seems like you're doing great. Why not? And that's the way our boards generally think. But what if they said, what else could we spend that $100 million on? Well, suppose you decided to hire a bunch of PhD research scientists or engineers to develop new products for you. If you pay them $100,000 a year, it was a pretty darn good salary for most of these folks, right? And you have another $100,000 a year for their lab equipment and assistants and everything else. That's $200,000 a year, right? You can hire 500 of them with your $100 million. Which is going to probably do your company more long-term benefit for you and all your shareholders? The 500 new scientists or the one CEO? Now, of course, you can debate that. It's not 100% clear. Maybe that CEO really is that great. But unless you've done the comparison, you're making the decision without having truly examined the facts. And the third one, what's your share of the $17 trillion US debt? It's over $50,000, which means a family of 4 owes $200,000 to future generations. That's more, by a lot, than the average family owes on their home and all their other debts put together. And yet, how often do you hear people talk about it? Not too often. It comes up, but not that often. Statistical thinking. There was the famous statement about statistics being lies, damn lies, and statistics, right? But I like to think of it as truthiness in statistics, if you know Stephen Colbert. Because the fact is, statistics is a way of getting at the truth. It's the only way in many, many cases. But if you do it in a truthiness way, right? That's what Stephen Colbert calls truth that comes from the gut instead of from the brain, right? If you do it in a truthiness way, then you're going to be very misled. So here's an example. Adjusted for inflation, income over the past 3 decades has been either stagnant, rising less than 10% over the last 3 decades, or risen significantly by more than 27%. You'll notice this is not a multiple choice question because they're both true. Right? You know, right? The first one is the median, the second one is the mean. But most people don't know the difference between a mean and a median. So they hear one side or the other quoting the statistic that fits their particular belief, and obviously they're going to be misled without understanding that. So we need to be able to explain those kinds of things. Just give you a couple of other quick examples of the statistical thinking and how important it is to our lives. Take airbags in cars. A lot of people said we should put, this back 10, 20 years ago, we should put airbags in all the cars to save lives. And then people started looking at the data after we put airbags in cars, and sure enough, they were saving lives for adults. But children were dying in higher numbers than before. How could that be? The statistics pointed them to a problem. And as you all know, the problem was kids in front seats, right? So we changed the rules so that we don't have that problem anymore. But without the statistics, we would have never known. Today, there are a lot of states who are considering passing laws to ban talking on cell phones unless you have a hands-free device. Why? Because it seems very logical that the danger of a cell phone comes from having your hand away from the wheel, right? Right. People started looking at the statistics at places that had gotten to hands-free devices. That led the University of Utah and a few other places to start doing laboratory studies. Turns out it's got nothing to do with your hand. It's the distraction. And keep this in mind and tell all your students. Turns out talking on a hands-free device makes you as dangerous as a drunk driver. If people knew that, they probably wouldn't do it so much. They don't drunk drive anymore, right? MAD has had a big impact on the way people think about driving. They don't drive drunk at the rate they used to because people have gotten that message. It's not a good idea. But they haven't gotten this message yet. The Transportation Department says almost 2 million accidents a year are caused by some form of distracted driving. And of course, if they're texting, it's far, far worse, because now they're distracted and not looking at the road. All right, we'll go to another question. Your best strategy for getting an extra $1 million to spend, everybody wants an extra $1 million, right, is A, wait for the lottery to have an unusually large prize and then buy a lot of tickets. That, of course, is the preferred strategy for most Americans who spend a per capita amount of about $500 a year on the lottery. B, develop your athletic skills in hopes of becoming a professional athlete. You know, there's these basketball players in the March Madness tournament who that's turned out really well for. Statistically, of course, 3 in 10,000 high school male basketball players will ever be drafted, let alone then have a long career. C, go to college. D, invest in the stock market. E, get a restaurant job in hopes that you can move up the ranks to management. Well, D, invest in the stock market. Turns out that's kind of like playing the lottery, right? Well, you won't lose as much, but you're not going to do much better than chance there either. E, get a restaurant job in hopes that you can move up the ranks to management. That's actually a pretty good strategy for getting the extra $1 million, because if you move up into management, you can do quite well. The problem with that is it's not the answer, because you can't do E unless you did C first. You're not going to be moving up to management if you don't have that college degree. What are the numbers? Let's do the math. The median salary for someone with only a high school degree, a high school graduation diploma, is $36,000. The median for a college grad is, four-year college grad, is $64,000. That's a $28,000 per year difference. Multiply that by a 40-year career, say from age 25 to 65, and that's $1.1 million just for going to college, median. Right, right. So those are medians, but but in addition to that median college grad earning more than $1 million more than the high school grad, they also have half the unemployment rate. And in general, I know it's not always true of math teachers, unfortunately. Our society has sometimes some weird priorities, but you're happy at least. Majors in math and science tend to be more than the median. Other majors tend to be less. So you can give this to your students as an example of why college really pays off. And the better grades you get, the more likely you are to do well. Let's see. Oh, it's working. All right, let's go to another topic here. So rank according to the percentage of income what each person pays in federal taxes. So this is what we call a ranking task. Instead of multiple choice, you have to put them in the correct order. Good type of question, by the way, if you haven't used this with your classes, because multiple choice, you know, if it's five answers, you've got a 20% chance of guessing right? Ranking task, you've got permutations on the 5, so a lot harder to guess. So who pays the most taxes in what order? A is a fast food worker earning $9 an hour. B, a teacher earning $60,000 a year. C, a self-employed businesswoman earning $110,000 per year. D, a mid-level executive earning $220,000 per year. And E, a billionaire investor. And of course, I chose these numbers because they work out easily in the averages based on the tax tables, right? Well, who pays the lowest amount of taxes? A, you would hope it was the low-paid fast food worker, and it is. They pay the lowest amount in taxes. In fact, they may even have an earned income tax credit, having money coming back to them, depending on the situation. But who pays the second least in taxes? Well, here it's really interesting because, as Warren Buffett made famous, before last year, he paid the next lowest, right? The billionaire investor. However, fortunately or unfortunately, depending on your point of view, if you're a billionaire or not, probably not, The billionaire went from the number 2 position to the number 3 position after last year's tax changes. But the really interesting thing is, you know, look at your mid-level executive earning $220,000 per year and your self-employed businesswoman earning $110,000. You would think she should pay less than him, but it's the other way around. Why? Because she has to pay the full self-employment tax, FICA, the employer's share, and the employee's share. And that more than makes up for the difference in the rates. So what's so important about this? Well, taxes are something that everybody in America gets fired up about, right? Especially this time of year. Now, you can ask yourself, whatever you feel about taxes, ask yourself, does this make any sense? And I would challenge you to find anybody on any end of the political spectrum who would say this is good the way it is. Everybody's going to agree it's crazy this way. Some may say it's crazy because the billionaire shouldn't be paying anything in capital gains, right? You have the right to that opinion. But don't argue without facts. And that's what too many people do. And if everybody saw these facts and understood them, they'd all be calling their congresspeople and say, do something. Right now, there was a Republican congressman, Camp, who proposed some changes. And what happened? You stopped hearing about him a day or two later because nobody wants to touch it, right? We could tell everybody, the politicians, you need to touch it. You need to figure out something that will at least make more sense than what we have. But if we don't have the facts, then we don't know. And it's also amazing to see some of the really simple misconceptions that people have taxes. They think that if you're in a 25% tax bracket, you pay 25% of your income in taxes, not realizing that the brackets are graduated, that there's exclusions at the bottom, and so on. You'd think that people would just look at the total amount they pay and go, wow, that's not 25%. But they don't. Why? Because they're bad at math. They're afraid to look at it because of that social disease that we have, that we're going to eradicate. Energy math. Let's suppose you had a nuclear fusion power plant and you hooked it up to your kitchen sink. Now, what am I talking about here? Now, we have nuclear power today, but the nuclear power that we have today is nuclear fission power. We split uranium atoms to make power. Fusion is the way the sun makes energy. It takes hydrogen atoms and fuses them into helium. We know how to do that really quickly. It's called a hydrogen bomb. We don't know how to do it in a nice, slow, gradual way to make energy. We would like to know. But let's suppose that we figured it out. And then we took our little Mr. Fusion, right, just like in Back to the Future, remember? You took your little Mr. Fusion and you hooked it up to your kitchen sink. Why your kitchen sink? Because your kitchen sink, if you turn it on, has water. And water contains hydrogen, which is your fuel that you need. So if you would allow us to borrow your kitchen sink and take the water, just leave it on. We're going to run your water bill up. Hope you don't mind. And leave the water running all the time and take the hydrogen out of the water that's flowing through it. You know, it's about 3 quarts a minute or so that you'll get out of that. What could you do with that energy that you would generate? Could you power your house, your block, 500 homes, Charlotte, the entire United States? You know, you give this question to students or typical Americans, and they'll guess one of these. They're just guessing because they haven't done any calculations. And they'll always guess one of A through D because E is so obviously ridiculous, right? You can calculate it very easily. You can figure out how much energy you get per fusion reaction. That data is easily available. How much water is flowing through, how much hydrogen there is in the water, and calculate the energy you get. Turns out to be 3 terawatts, which is more than the entire United States uses from all energy sources put together. More than all our oil, coal, gas, existing nuclear renewables. If we had a nuclear fusion power plant, we could stop using all other forms of energy and just use your kitchen sink, as long as you don't mind. Let's think about that a little bit. What are we replacing? Well, we use in the United States an oil equivalent. Now, of course, some of it comes from coal and gas and other sources, but if you convert it all to oil equivalent, we use 74 million gallons of oil per hour. in this country. That would all be replaced by your kitchen sink. We also spend a lot for that oil, not just the cost of it, but for example, the NIH says that we spend $120 billion a year on direct pollution-related costs. That's people who end up in the hospital for asthma. Doesn't even count missed days of work for mild asthma and things like that. The Department of Defense says we spend $100 billion a year on oil security, protecting the oil supply. That's only the standard built-in cost. It doesn't include the cost of any wars or anything else. And we haven't figured in any environmental costs into this at all. So right off the bat, we've got a couple $100 billion that everybody agrees we're spending, even under the most conservative possible assumptions, which works out to about $1.50 per gallon of all the oil we actually use. So we're subsidizing this oil at $1.50 a gallon. How much are we subsidizing the search for fusion? How much should we be subsidizing the search, given that we could replace all this with your kitchen sink? Well, you could have an opinion on that, but it turns out the answer is we spend $400 million a year as a nation on fusion, which is 0.0001% of the federal budget, for something that could completely transform our entire energy economy if we figured it out. Now, maybe you think we shouldn't spend more on it because it's too hard to figure out. Some people think it is too hard to figure out and that we won't get there. I think they're being pessimistic, but let's just say, well, that's not the only way we could do it. How about solar energy from space? According to some estimates, we could do that, replace all our energy with solar energy from space for a couple $1 trillion, which sounds like a lot of money, but compared to what we spend on energy, it's not. A couple years worth. Biofuels, other things. We invest very, very little while spending this huge amount on our existing energy sources. Why? Because we're not thinking it through carefully. And then I like this topic because everybody's interested in our polarized politics today, and they want to know, why are our politics so polarized? It turns out the answer is math. So here's a simple question. Suppose a state has 8 seats in the House of Representatives, and the state goes exactly 50% Democrat in their vote and 50% Republican in their vote. How many seats will be won by Republicans? How many of the 8 seats? And your choices are that the Republicans will win 4 of the 8. They got 50% of the vote, 3, 4, or 5, 2 to 6, 1 to 7, or all the elections will be ties. Well, of course, they won't all be ties, although a lot of students like to pick that answer at first, right? If it's 50-50, they think it's going to be a tie, but forget, one vote out of hundreds of thousands can break a tie. So what is the answer? The answer is D, 1, 2, 3, 4, 5, 6, or 7. And it's not hard to see why. Take a simple example. Suppose your state has 4 million people. So each district has 500,000, your 8 districts. These 2 million voters, or 4 million voters, are evenly divided, 2 million Democrat, 2 million Republican. But imagine that you could somehow draw your districts to put one district that has 500,000 Democrats in it. Right? Then the Democrat's going to win that district with 100% of the vote, right? That means the other 7 remaining districts have 2 million Republicans and 1.5 million Democrats among them, which means if you can divide them up evenly, the Republican will win a landslide in every one of the other 7. And, of course, it's not realistic to pack all 500,000 voters from one party. But thank you, North Carolina, for providing an example that gets as close as we can. These are the districts in North Carolina, and I know, again, you can't see them from the back there, but there's some really weirdly shaped things in here. Why are they so weirdly shaped? Because they're being drawn to try and accomplish what I just talked about. In 2010, the districts used in North Carolina were the ones that had been drawn in 2000 by the Democrats. In 2010, the Democrats won only 45% of the statewide vote, The Republicans got way more votes statewide than the Democrats. And yet, the Democrats won 7 out of 13 of the state's congressional seats. They got a majority with a minority of the vote. In 2012, the districts had been redrawn, this time by the Republicans. The Democrats actually did much better in the election. They got an actual majority in 2012, 51% of the state vote in North Carolina, but won only 4 out of the 13 seats. That is the power of redistricting. Regardless of the way your state votes, who gets to draw the districts gets to decide who's going to win. If everyone understood that, there'd be a huge uproar about gerrymandering. Doesn't matter which party you belong to, it shouldn't be subject to these kind of vagaries, right? And so for the last slide here, I'll say, bring you to one of my favorite quotations, which is from H.G. Wells, written back in 1920. Human history becomes more and more a race between education and catastrophe. And you can see, whenever we don't understand what we're doing, we veer off towards catastrophe. When we do understand what we're doing, we're usually able to make some pretty smart decisions. The problem is not being informed. And here, I hope I've shown you a bunch of examples from math where if you're not mathematically informed, it's going to be really difficult for you to make intelligent decisions. And we've been living in a country where no one has informed the vast majority of our students with any of these ideas because they weren't part of the traditional mathematics curriculum, even though they're very obviously and clearly mathematical. And that's why I'm so excited that you've all changed that. And hopefully the rest of the country will follow in your footsteps soon. So that's pretty much where I'll end. I'll just show you a couple last things here, and then we can open it up to questions. I think most of you, so this is the book I've been taught. All the examples I gave you are from Math for Life. The same examples all also appear in my textbook, Using and Understanding Mathematics, because this is the trimmed down version from that for the public. And I also have statistical reasoning for everyday life that takes the same approach to statistics. And then if you watch, oh man, you can't hear it. Darn.
It's story time from space. Now today's story is Max Goes to the Moon, a science adventure with Max the dog.
So I just wanted to show you that because I'm really excited about it. So, so somehow a couple of years ago, one of the astronauts got a hold of one of my children's books and called me up and asked if he could read it from the space shuttle. And so he read a PDF of Max Goes to the Moon from the space shuttle. And that apparently got them excited enough that they said, how about if we take the actual books up to the space station? So my 5 children's books that you saw earlier out in the, they're there, are actually all orbiting Earth at 17,000 miles per hour right now. The videos of the astronauts reading them will be posted for anyone in the world to look at freely. They've been read in English so far, but they're going to be read in Japanese. And they're supposed to be read in Russian also, but that was before the Russians and the Americans got really mad at each other. So I don't know what's going to happen with that. So those videos will all be posted freely for anyone. I hope you'll all go to the Facebook page, Story Time from Space, and check the like box for it. And I'll have one more favor to ask you, which is if you did get to read Math for Life and you liked it, please post a review on Amazon. Those really help a lot. And that's where I'll stop. Thank you very much. And I'm happy to take questions until Suzanne kicks me out. So.
Is that redistricting map of North Carolina in one of your books?
In Math for Life, I have the 2010 map. So the 2012 map's not. But they're easy to find online. You can find all the states. In fact, type in a most gerrymandered district into Google, and you'll find some that have the most insane shapes. Not necessarily in North Carolina, in other states. I think Maryland has the #1 most gerrymandered district. So Gerrymander is the term for drawing the districts these ways, and it comes from back in the 1800s. There was a governor in Massachusetts named Gerry who drew districts, and somebody said the district was shaped like a salamander, and then a cartoonist called it a gerrymander, and that's where that term comes from.
Yeah, I read your book. You talked about, at the end of your book, you talk about reforming the education. Other people who have contributed to education here have talked about transforming our educational system. So I don't know where you find a niche between the transformation and the reformation of our educational system in this country.
So the question is about the difference between reforming the system and transforming the system. And you know, I think you can probably have a lot of debates about how much real transformation versus reforming is necessary. My own opinion is we know how to teach people stuff. You know, that's why we've got PowerPoint here, and the Greeks had only tablets to write on. We've been pretty successful at educating people for a very, very long time. What we haven't been successful at is mass producing the education for everyone. And so I don't know so much that we need to transform everything, but we need to make sure that everybody is using the best educational practice and teaching the most meaningful things. And in mathematics, it's true going all the way back to the early curriculum. Mathematics tends to be taught without context. It's taught as a pure abstraction. And of course, you know, there are mathematicians who love that approach, right, because they deal in abstractions all the time. But for most people, without context, they don't see the point. And I think a lot of this is just having the context be there. I call it the difference between a context-driven approach and a content-driven approach. All of our current teaching is content-driven. We say, what mathematical topics do we want to teach? So, and then we put them in the curriculum. And then if we have time, we give the students a few examples of how those mathematical topics have some relevance to their lives. But of course, you can see the difficulty with that, which is by the time you get to the parts that would actually be interesting to most students, you've probably already lost them. Context-driven, you turn it around. You say, what important topics are there that our students should know about? And then you say, what mathematics do we need to explain that to our students? And in the end, you'll probably end up with the same basic set of mathematical topics covered, but by starting with the context, your students will stay engaged, whether they're, you know, in 8th grade algebra or a quantitative reasoning course or even in advanced calculus. If you give them the context, they're more likely to care about what's going on. More questions? You have to have more questions. All right, well, thank you very, very much. I really appreciate you having me here.